Okay, so class, we proceed to question 15C. Now we have a 2 ohm resistor we attach to the circuit in series with the EMF E2. Okay, we connect to the battery E2, external resistor 2 ohm. So this will causing the balance length of the wire now at 68 cm. Find the internal resistance of EMF E2. So the EMF E2 have internal resistance, so we want to find the internal resistance in the EMF E2. Okay, so class, so now the balance length already changed to 68 cm. Where balance length means when our G reaches 0. Okay, so before we start to solve the question, we draw out first the informations that we already know. Okay, so as usual, to be more systematic, we put it in form of table because we understood that voltage is proportional to the resistance and also the length of the wire. So kita put all the informations we have from the question A and also question B. So when our EMF battery 5 volt, that one in the primary circuit, just now kita kata kita bagi kepada resistance 0.5 ohm and also the whole wire AB of 2 ohm. Okay, then we consider the voltage across the wire only. So just now from question B, we already calculate the voltage across the whole wire AB is 4 volt, whereby the resistance of the wire is 2 ohm, the length of the wire is 100 cm. Okay, then only we proceed to the balance length. So the voltage across the balance length kita denote sebagai AC. So the length, the balance length when the G reach 0 is 68 cm. Okay, so that one is the informations we know in the questions. So we want to determine the internal resistance of the EMF E2. So in order to find the internal resistance R, kita kena dapatkan dululah berapa voltage bila our G reach 0. So class, now we connect a resistor to the E2. So when we connect a resistor 2 ohm to the EMF E2, then we will find out that when our G reach 0, our voltage across the AC is not equal to the EMF of the battery. Kita tak boleh kata voltage across AC tu sama dengan EMF of the battery, seperti yang kita nyatakan dalam soalan sebelum ni. So soalan sebelum ni kita kata bila G reach 0, the balance length, voltage across the balance length is equal to the EMF of the battery. But then now we add in an external resistor to the battery. So the voltage during the balance length AC is not actually equal to E2 lagi. Instead, now it will be equal to the voltage across the external resistor. I mean the resistor 2 ohm. So actually now when our G reach 0 at the balance length, the voltage AC actually will equal to the voltage, the terminal voltage across the 2 ohm resistor. Okay, across the 2 ohm resistor. So sekarang kita punya Waktu balance length, bila G baca kosong, voltage AC ni, the voltage AC, saya highlightkan. The voltage AC now will equal to the voltage across the 2 ohm resistor. Dia akan setara dengan voltage across the 2 ohm resistor. So, kita tulis dekat sini lah. So, the VAC will equal to the voltage across the 2 ohm resistor. So, kita dapatkan dulu berapa voltage across the 2 ohm resistor. Barulah kita boleh relate dengan EMF of the battery dan determine the internal resistance of the battery. Okay, so again kita gunakan potentiometer kita. Kita gunakan maklumat atas ni, kita gunakan ratio ni untuk wire tersebut. Kita dapatkan berapa voltage across the 2 ohm resistor. So we apply ratio voltage equal to ratio length. So 4 volt over voltage 2 ohm equal to 100 cm over 68 cm. So when we do our calculations, we will get the voltage across the 2 ohm will be around 2.72 volt. Okay, so after we get the voltage across the 2 ohm, then we can focus on the circuit below. So kita consider the battery, okay, E2, the value is 3 volt that we determine from question 15A. Then we connect it to an external resistor, 2 ohm. Okay, so there is a current flow across this resistor is I. Jadi, kita gunakan Ohm's law. Voltage 2 ohm, the terminal voltage is IR. So, we determine the current that flow out from the battery 3 volt that passing through the 2 ohm resistor. So, the voltage is 2.72. The resistance is 2. So, we get the current that flow out from the battery that flowing towards the 2 ohm resistor will be around 1.36 ampere. Okay, so after we get the current, then kita bolehlah relate with the external resistor, the EMF, in order to find the internal resistance. So we have the internal resistance is the current multiplied external resistance plus internal resistance. Kita ada formula ni untuk EMF battery. So, the EMF of the battery is 3 volt. The current that flow out from the battery is 1.36. So, the external resistance is 2. So, we can determine the internal resistance. So, we can determine the internal resistance R. Okay, so you might pause the video to do the calculation. So, the R will be 0.206 ohm. Okay. So, I minimize it. So, class, apa yang anda kena faham di sini ialah, you kena ingat, kalau kita ada connect satu external resistor kepada battery bawah ni, dan bila G baca kosong, the voltage across the balance length will equal to the voltage across the external resistor. Okay? So then we already solved question 15.